Alright. There are, just like when we talked about proving triangles congruent, okay, we had 5 ways. We had side, 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 angle, side, angle, 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 side, and hypotenuse leg. There are also ways to prove that triangles are similar. Okay, there's actually only 3 ways to prove triangles are similar, and we're just going to look at one of them today. This one is called angle-angle similarity. If I can show that 2 angles of one triangle are congruent to 2 angles of another triangle, the triangles are similar. Okay? That's all we need. 2 angles, one triangle congruent to 2 angles of another triangle. So, in this first example, I've got angles B and D congruent and angles A and D congruent. Triangles are similar. So we could write a similarity statement matching up congruent angles and say triangle ABC is similar to triangle. If we match up corresponding pieces, that would be DEN. In example 2, the angles that we have, A and F, are obviously not congruent. We do have B and D congruent, but we can easily check then to see if C or D would have the same measure. I could take 180 minus 81 minus 60 to get this measure. Similarly, 180 minus 81 minus 39 to get that measure. So if we do that, what do we get? 39 for this one, right? And 60 for that one. So A and D are congruent, right? And C and F are congruent. So we do have that these 2 triangles are similar. We actually showed all 3 pairs of angles were congruent here.
How could it be similar if the third angle not?
They are.
Still the same.
81, 81,
yeah,
60,
yeah.
60, 39, 39. So if you remember, way back, we didn't spend much time on this, but we had something called the third angle theorem, where we were able to show that 2 angles of 2 triangles were congruent. Third angle is automatically congruent. So we could, again, write a similarity statement here. I could say a triangle ABC is similar to triangle, let's see, so A matches up with B, B matches up with E, and C matches up with F. Okay. So if we are just able to show that 2 pairs of angles are congruent, I can claim that the triangles are similar. Questions? All right, then let's take a look at a couple of the exercises down below here and see if there is enough information to show that these triangles in each example are similar.
No way.
Alright, here are the answers for these. Okay, the only one that ended up not being similar was number 6. For 1 through 5, we could show that they are similar. Right, and then also writing a correct similarity statement to match up corresponding pieces. Any questions on these? Number 2. So on this one, we're not actually given any pairs of congruent angles, right? We're just told that WV and YZ are parallel. That's what the arrows mean. So if these lines are parallel, cut by a transversal, I can say these alternate interior angles would be congruent, and then also these alternate interior angles would be congruent. So there's two pairs, and then we could also even say that those are vertical angles. So we would have a third pair, but we only need two. So other ones? Three. So on this one, we've got, again, just a pair of parallel lines. So if we've got parallel lines cut by first this bottom transversal, this angle U and then angle TLS here would be corresponding angles. So I could say they are congruent. And then same thing up here. I can say angle R and angle TSL would be corresponding angles, so they're congruent. So I can say the big triangle is similar to the little triangle. Other questions on this? All right, then flip over to the back. All right, and on the back, we just have a few more examples of setting up and solving proportions, right? But sometimes we may first have to show that the triangles are similar in order to set up a proportion, or this actually, example 2 is a pretty common story problem dealing with this idea. So if we look at example 1 here, we're told triangle KJL is similar to triangle MNL. So we need to make sure we're matching up correct corresponding pieces. So if I look at my statement here, I can see JL matches up with NL, JL and NL match up. So I could write that as a proportion. And then I also know that KL would match up with ML. So I can say that's X over 15, really similar to what we did yesterday. Cross multiply. Divide by 10. We get X equals 18. In example 2, it says we've got a 4-foot tall person, really short person, casting a 3-foot-long shadow at the same time that a telephone pole casts a 9-foot shadow. How tall is the telephone pole? Well, if the sun is creating shadows, we know they're going to be proportional to the height of whatever the object is that's casting the shadow. So we can set up proportion as 4 over 3 equals X over 9. Okay. The only thing we need to make sure of is we're consistent. Okay, so since I put this side of the triangle over this side, like the height over the width, I have to be consistent and say height over width for this one. So cross multiply, divide, get the height of the flagpole or the telephone pole would be 12 feet. Questions? So then in the exercises down below here, it first asks us to identify the similar triangles and then find each measure. Right? Actually, I want to do one of these together first. Let's do number 4 together here. We've got a triangle inside of a triangle. Whenever we have a situation like that, it's going to be beneficial to draw the two triangles separately. So if I draw this little one, I can see it. I've got these sides of 32 and 30. And then if I draw the big one, the sides, I know this side would be 22. What would the length of this entire side be, right? 40. And then the length of this side, 32 plus x. Okay, so then it's much easier to see what sides we can set up in our proportion. Okay. Questions? All right, let's take a few minutes then and try a couple of these. Remember, first, identify the similar triangles, so write a similarity statement. Then, set up and solve a proportion. Yes, you can.
some or square root.
You combine it first.
Yeah, things that you combine A and B if you can. Use square root. But you don't need to do square.
I was gonna say something, but I lost my train of thought. I lost it. Oh wait, did I do this one right?
256. 256.
You just say 156.
256.
No. Kidding. What's that? 16.
That would be 8-ish.
Okay, and now what is 9?
4.5.
What is 9 half?
Just double check.
256.
No.
You're at 10.6. Well, it's 10.6.
You know, 32 divided by 3. That's better.
This is silence.
No, he's 9 feet tall, baby.
Oh yeah, I'm sorry. Yeah.
Thanks for
This is him laying down.
It's him laying down. 9 feet tall.
But what I see is she's like.
It's around 6'4".
What?
Not this one.
Yeah, we've been doing stuff on the back.
Alright, here are the answers.
Mr. Fach, ever bring up a baby in your hand?
Let's go number 4. Number 4. So, we already drew our separate triangles, right, to show that we've got 32, 30, and 32 plus x, 40, and 22. So, we can use these two sides to set up a proportion. So I can say 40 over 30 equals 32 plus x over 32. And remember, right, if we have large numbers or a large fraction like this that can be reduced, you can go ahead and reduce that to make the arithmetic a little bit easier. So 40 over 30, we could actually just reduce to 4/3. That'll make the math a little bit nicer. Then cross multiply, so we'll end up with 3 times 32 plus x equals 4 times 32, so 128. Distribute the 3, so 96 plus 3x equals 128. Subtract 96. 3x equals 32. Divide by 3. We get x equals 10.6 repeating, or 10 2/3.
I can get this.
You would guess correctly.
Why?
Any other questions?
I did my own.
Alright, here's the homework.
You have to know the
take a picture of it.
That's an imposter.
Take a picture of it.
Enemy imposter.
Those are the ch-
No, that's the real deal.
I opened it.
That's the real
I
one.
think you're an imposter.